You know that old metaphor about the boiling frog?
Oh, yeah. A bit grim, but effective.
It's a cliche for a reason, right? You drop a frog in boiling water, it jumps out. But if you put it in tepid water and just slowly turn up the heat,
It just sits
it
there.
sits there, it gets comfortable, adapts until, well, it's soup.
A very effective way to describe human complacency, unfortunately.
Exactly. And looking at the stack of research we have today, I really have to ask, are we the frog?
Mm-hmm.
Because the temperature of the water we're swimming in, this huge chaotic ocean of artificial intelligence, it's rising fast. And the question isn't just, is it hot?
Yeah.
But do we even know what hot means anymore?
That is, I think, the precise question that's being posed by the material we're diving into today.
Okay, so what are we looking at?
It's a massive collection called Let's Talk AI, and I want to be really clear about what this source is. It's not just a blog post or one person's opinion. It's a synthesis of insights from over 30 expert dialogues. We're talking editors like Barbara Steffen, Edward A. Lee, Bernhard Steffen. I mean, they're pulling together voices from computer science, law, philosophy.
Business, all of it.
Yeah.
A real heavy hitter of a document.
Yeah.
And this subtitle really gives the game away here. Interdisciplinarity is a must. Which, I'll be honest, at first glance, it sounds a bit like, academic word salad.
It does.
But as we dug into the notes, it's really more of a survival guide.
It absolutely is. The core premise they set up right at the beginning on their motivation slide is that we're in a technological arms race.
And the scary part isn't just the speed.
No, it's that this race risks becoming, and this is their word, incomprehensible.
Incomprehensible and out of control. That's a direct quote from the preface.
Yeah.
So the mission for this deep dive is pretty clear. These experts are basically arguing that now is not the time to rush. It's time to hit the pause button.
Or at least the slow motion button.
Right, and just reflect. We need to make sure this progress we're seeing is deliberate, not just accidental.
But deliberate is hard. When we're fighting our own psychology, we're going to walk through the logic they laid out step by step, and it starts in a place you might not expect.
Not with the code.
No, not with the code, but with our own heads.
Yeah, let's unpack this paradox of the AI age. I was looking at the stats they compiled on cognitive dissonance, and it really stopped me in my tracks.
It's a very distinct tension, they point out.
Okay, so look at these numbers. They found that 61% of people explicitly distrust AI applications.
That's a solid majority.
A solid majority.
Yeah.
We don't trust the robots. But then you look at the usage column. 63% of people use AI applications often.
And that's the gap. That is the cognitive dissonance. We distrust the machine yet.
We depend on it.
We completely depend on it.
It's like, okay, you remember the privacy paradox from the early social media days. We all said, oh, I hate that this app tracks me, but we kept scrolling.
Because you wanted to see the vacation photos.
Yeah, exactly. Is this just the same thing?
It's similar, but I think the stakes are just significantly higher. The source material argues that pure convenience, is completely outweighing our trust concerns.
So we're building on a fragile foundation.
That's the exact phrase they use. Think about the implications of that. In the social media era, the risk was what? Targeted ads?
Maybe some data leakage?
Right. Here, we're talking about integrating tools we fundamentally do not trust into our healthcare, our finance, our legal systems.
Okay, so what happens when that utility falters? Or when one of these systems makes a really critical error?
The foundation cracks.
Yeah.
You just can't build a stable future on a tool that most of the population views with suspicion. It creates this inherent volatility.
Right.
If a bank's AI fails, and nobody trusted it to begin with, the fallout isn't a technical glitch. It's a collapse of institutional confidence.
And so we have a trust crisis. But before we can even try to fix that trust foundation, the experts point out this massive hurdle. And this is where that whole interdisciplinarity thing starts to really make sense. We don't even agree on what we are building.
This is lens one, the definition problem. And this is where the document gets fascinating. You'd think that with 30 experts, people with PhDs and tenure, they could agree on a simple definition of artificial intelligence.
But they couldn't. It's a mess.
A complete mess. It's a kaleidoscope of perspectives. You have 30 experts and, basically 30 different definitions.
Okay, so let's look at a few of these because the contrast is wild. You've got Carl von Wendt, coming from a sci-fi background.
Right.
He defines AI as simply the automation of complex decisions.
Clean. Simple.
Very clean. But then you look at Georg Borchs from the legal field. His definition is methods to enable machines to perform tasks similar to human thinking.
Similar to human thinking. That's a huge pivot right there.
It's huge.
It is, because for the lawyer, the benchmark is the human. It's all about mimicry and ultimately liability.
And then you have Ellen Enkel from the business side, who doesn't seem to care about the mechanism or the mimicry.
No, not at all.
She defines it purely by its impact. The potential to change our way of working and living.
So you have a decision maker, a human mimic, and a societal shift.
So why does this matter? Isn't this just, academic semantics?
I would argue this is actually the most dangerous part of the current landscape. Think about the consequences. If we don't align our vocabularies, we cannot possibly regulate the technology effectively.
Can you give me a concrete example?
Sure, imagine a self-driving car crashes. The engineer, using von Wundt's definition, might say the car did its job perfectly. It made a complex decision based on its inputs.
So a success.
A success from that perspective. But the lawyer, using Borges' definition, argues it failed to act like a human driver would have.
And you're in a deadlock.
A total legal deadlock, because they aren't even describing the same reality. The engineer sees a working machine, the lawyer sees a negligent driver.
It's like trying to regulate vehicles when one person means a bicycle and another means a warp-drive starship.
That's not an unfair comparison at all. And this confusion leads directly into their lens 2, the trust equation.
Okay.
If we can't define it, how can we possibly trust it? The sources visualize this as a scale, which helps explain that paradox behavior we talked about.
On one side, overtrust, and on the other, undertrust.
And we seem to be guilty of both at the same time.
Yeah, the overtrust side is that convenience trap. We trust the GPS because it's easier than reading a map. We trust the spell checker because we're lazy.
That's the utility trap. But the undertrust side is more complex. It comes from the lack of explainability.
Right, the famous black box issue.
The black box. Data goes in.
Magic happens.
Well, I wouldn't call it magic, and the engineers definitely wouldn't.
Fair enough.
It's math. It's
Well,
just high-dimensional statistics on a scale that the human brain cannot intuitively track, and that's where the calibration failure comes in.
So it's not that it's cosmically inexplicable, it's just inexplicable to us.
To us, in real time. And that distinction matters immensely. The source highlights this fascinating inversion. You have non-experts, the general public, who often overtrust persuasive systems.
Right, if the chatbot writes a confident essay, we assume it knows what it's talking about.
It sounds smart. It has good grammar. But on the flip side, you have the actual experts, the people building these things, who often undertrust the systems.
Why?
Because they know it's just a statistical probability engine. They know how messy the data is. So they might reject a perfectly valid system simply because they can't explain how it reached that specific conclusion.
So the experts are skeptical because they know too much, and we're gullible because we know too little.
In a way, yes. So the goal isn't just more trust, it's calibrated trust. We
Yeah.
need to match our perceived trustworthiness with the machine's actual capabilities.
Stop treating a probability engine like an oracle.
Precisely.
Speaking of oracles, let's talk about the future. Everyone wants to know. When is superintelligence arriving?
The capability spectrum. The source lays this out on a scale of 1 to 10. And if you thought the definitions were scattered.
Just wait till you see the timelines. Yeah, I looked at this chart. You have the skeptics like Kevin Baum and Mike Kinchy. They're basically saying relax.
Calm down.
AGI, artificial general intelligence, is
Yeah.
distant. Let's focus on the risks of the tools we have right now.
The narrow AI risks. But then you have the accelerators.
Like Carl von Wendt again. He
Yeah.
thinks an intelligence explosion is possible in 5 to 20 years.
It is. Soon.
That's within the mortgage I just signed. That's very soon.
It is. And then you have the optimists, like Edward Lee and Ellen Enkel, who argue there are no fundamental limits to AI's potential. They see the scale going all the way to 10.
But here's the kicker for me. Despite this huge debate about when the super robot arrives, the source claims there's a consensus on what matters now.
Yes, this is crucial. The consensus is whether AGI happens or not, the impact of current AI is already transformative.
We don't need to wait for a sentient machine to worry.
No. The water is already getting hot, to go back to your frog analogy. You don't need the water to be at a rolling boil to get burned.
So if the water's getting hot, what's the temperature? Let's talk utopia versus dystopia. I went into this expecting, just doom and gloom, Terminators and nuclear codes.
And what did you find?
I was honestly surprised. I expected way more pessimism, but the stats. 13 experts held balanced views, 14 were more utopian, only 1 was fully dystopian.
It's a hopeful signal, but we shouldn't get too comfortable. The dystopian fears section had some pretty stark warnings.
Loss of autonomy, erosion of truth,
Hmm.
But there was one phrase that just stood out to me.
I know exactly which one you mean.
Weaponized stupidity.
It chills the blood a bit, doesn't it?
It does. Let's define that, because it sounds like an insult, but it's actually a very specific technical threat.
It is. Weaponized stupidity isn't about making people dumb.
Yeah.
It refers to using AI to generate plausible sounding but factually empty noise.
At scale.
At a scale that completely overwhelms human critical thinking. It's a denial of service attack on our cognitive processing.
A denial of service attack on our brains. That's a terrifying way to put it.
Because if you can't filter truth from noise, because the noise is infinite and generated instantly by machines, you check out, you stop engaging.
And that dissolves the shared reality you need for a democracy to even function.
Exactly. But against that, they balance the utopian hopes. Climate solutions, personalized education, medical breakthroughs.
So the experts aren't predicting an inevitable dystopia. They're sounding an alarm.
They're saying this bad future is possible, but only if we don't act. The dystopia is the default if we do nothing. The utopia requires work.
So let's talk about the work. How do we act? This is where the source proposes a major mental shift, moving from asking how to asking why.
This is the paradigm shift from seeing AI as a tool to seeing it as a partner.
Okay, let's break this down. Because partner sounds nice, but we just established we can't trust the black box.
Correct. And that is the tension. When we view AI as a tool, we want to understand the mechanism. We want to see how the gears turn.
But we can't.
With deep learning, we can no longer explain how the neural network reached a conclusion. The gears are mathematical abstractions.
So if we can't see the gears, what do? Just blindly trust the output?
No. We engage in what the experts call post hoc rationalization. We need to treat the AI like a human colleague.
A human colleague.
Think about it. You can't see your colleague's neurons firing. You don't know the chemical interactions in their brain, but you can ask them, why did you make that decision?
Okay, but wait. If I ask Bob, the AI, why it rejected a loan application, isn't it just generating text based on probabilities? Is it telling me the truth or just what it thinks an explanation should sound like?
That is the billion-dollar question, and the source material tackles it head-on. You aren't getting a window into the code, you're getting a constructed narrative. But the experts argue we have to accept that narrative as the truth for regulatory purposes. We have to shift to auditing the process and the outcome, not the mechanics.
That feels like a huge leap of faith. We're basically saying we can't understand the brain, so we'll just judge the behavior.
Which is, ironically, exactly how we treat other humans.
Fair point.
But to do that, to actually audit these outcomes effectively, we need more than just coders looking at the screen.
And that brings us right back to the title of the collection, The Imperative of Interdisciplinarity.
Yes, they have this great visual, a star chart connecting different fields. Law, ethics, computer science, psychology, business.
And right in the middle, in big bold letters,
Translation needed, because no single discipline can contain AI.
take that loan rejection example.
Exactly. Computer science defines why the code generated the text, but law has to define the liability. Ethics has to define the red lines. Was it biased?
Psychology has to handle user trust.
And business has to figure out if this product is even viable.
And the problem right now is that these people are in different buildings, speaking completely different languages.
Yes. The source emphasizes that we need a shared vocabulary to overcome these semantic barriers. This pushes hard against that move fast and break things ethos of Silicon Valley.
You can't just engineer your way out of an ethical collapse.
No, you actually need the philosopher and the lawyer in the room during the build phase, not just coming in for cleanup after the crash.
So we've got the diagnosis, we're the frog, the water is hot, and we need a team of translators. What's the actual treatment plan?
The source wraps with a framework for responsibility, 4 really clear, actionable steps.
Okay, number 1.
Regulation. But not just any regulation. It has to be adaptive and proactive.
Meaning the law can't be static.
Right. If we write a law today based on 2024 tech, it's obsolete by 2026. The framework has to evolve as the capabilities evolve.
Living laws.
Yeah.
Got it. Number 2.
Education. And this isn't just teaching kids to code. In fact, coding is maybe the least important part of this point. They're talking about AI literacy. Training the public, you and me, to spot manipulation. We need to be immunized against that weaponized stupidity.
We need to know when we're being played by a bot.
Yes. Number 3, control. This is the safety brake.
Human in the loop.
Always. For critical decisions, healthcare, justice, warfare, We must reject full autonomy. There has to be a human accountable for that final button press.
If a decision can ruin a life, a human signs off on it.
Precisely. And finally, number 4, transparency. Data provenance and explainability are non-negotiable for trust.
Data provenance, so knowing where the ingredients came from.
If you don't know where the data came from or why the decision was made, you can't trust the system. It all goes back to that fragile foundation. Transparency is the concrete.
The final image in the source material is really striking. It's a human and a robot facing each other near what looks like a tipping point.
It's a moment of choice, and the verdict from these 30 experts is clear. The future isn't being written by the machines.
It's being written by the boundaries and guidelines we established today.
It's empowering, in a way. We aren't just passengers on this train,
We're laying the track.
if we choose to be. But, as the source concludes, interdisciplinarity is a must. Now is not the time to rush.
We need to slow down to speed up, or at least slow down to make sure we're not driving off a cliff.
We need to slow down to make sure we're building a world we actually want to live in.
So here's a thought for you to take with you. We talked about cognitive dissonance, that gap between not trusting an app but using it anyway. Think about the device you're listening to this on right now. Think about the algorithms serving you this deep dive. Do you trust them? And if they're working perfectly, keeping you entertained, informed, does it even matter if you trust them or not? That's the water we're swimming in.
That is the question.
Thanks for diving deep with us. We'll see you next time.